Assalamu alaikum. How are you, everyone? Can you all hear me? Can you hear my voice? Is it clear? Okay, great. Okay, welcome to our first virtual lecture. Okay, before I start, do you have any questions from last week face-to-face class? Let's do a quick review because I think we still expecting more past students. I will give you the permission to speak if you want. Okay, remind me what we talked about in the last week. In the last Monday. If you remember. You remember nothing? Nothing? Really? Come on. Okay. I will remind you. We talk about network. Okay? We talk about the type of data flow, simplex and haptoplex and multiplex. And we talk about the network types, LAN, WAN, MAN, PAN. And we talk about network topologies, yes, and we talk about the history of Internet and Internet administration. Okay? Do you remember this stuff? Are these stuff familiar with you? Yeah, thank God. Okay. Let's continue. We're still in the same topic. We're still talking about network. Believe it or not, the whole course is talking about network. So that we always gonna stay on the same topic, which is networking. But today we're gonna talk about network models, and I believe you all have an idea about network models. Okay? So go ahead and start. Can you all see the slides? Can you see Maria and Anne? Yeah, good, okay. Let's keep it simple, okay? If Maria wants to send a message to us, okay, let's say it's a direct message or a mail, okay? Even the simple process of mailing, it will go through several layers, okay? When Maria starts to, for example, call or try to write a letter to Anne, the first thing you will what? Create this letter or create this message by talking or writing. Okay? Then do you see my pointer? Can you see my pointer? Okay, you don't. Okay. Okay, I'll try to use a pen. Can you see what I'm drawing now? Red line. Okay, great. So, here's Maria starting writing a letter or talking. Okay. Then she will what? Go through a process called encrypt or decrypt. Okay. In case if you're talking on the phone, this will be the process of changing your sound waves, and to a signal. You go through the cable, whatever kind of cable. If you're talking through the internet or you're talking through the telephone or whatever, these your sound will change to either waves or voltage or whatever. Okay? Let's say it's like encrypt and decrypt, like عملية تشفير. Okay? So what is going to happen here? Your message will be encrypted. Okay? Then after that it will be what? Packaged. It will put in the envelope, for example. If you want to send a mail, you're gonna put it inside an envelope, and then it will go from your station, let's say, or your location, okay, to the other location where N exists. Here there is a server to handle this movement. This is the transfer process. It will take your message and then transfer it to the other location or the destination. Okay? Then the same process is happen when you transmit this message. It will happen again, but in the opposite side. They will open this envelope when Anna receives this envelope. Will open it. Okay? If it's letter, and then she will read it to encrypt that message. Or in case if it's a phone call or a sound, same thing. She will open the packet, and then the sound will come again from whatever form it is. It's a wave or voltage or whatever. It will come back and decrypt, يعني فك تشفير, to become a sound again, and then going to hear your message. Okay? So this is a simple mailing process, or let's say a transferring data, okay, from location to other location. Okay? It's the same thing what happened when data moves from a node to node within a network. Okay? It will go through different layers, then it will transfer from your network to other network, okay, to your final destination. Good? Okay, let me try to share that slide with you. Okay. Can you see my slide? Can you all see the slide, network model? The one that okay, good, great. Okay. If you want to talk about models, let's describe what is model. What I mean when I said network models. Anyone of you have an idea what is network models? It's kind of structure. It might be a structure, but structure for what? For network. Of course it's for network, because it's network model. Yeah, but what is it? What does it do exactly for this network? What is it? What does it describe? Yes, good. It's the model usually describes how the data is traveled from node to node within the network. I think I said that before, right? Yeah, I just said it. If you were focusing with me, you will know. So network models is describing or how you can understand how this data will move or travel from source to a destination. Of course, inside the network. Okay. There are two types of models have been developed, and you tell me what these two types of models. I'm certain you know it. What is the main two network models? Yeah, great. TCP, IP, and OSI. Good. So, today we're going to talk about both of them. We will go through details a little bit. TCP IP model was created or was developed in 1970. Okay, and after a decade later, the OSI has been developed. That means what? Who comes at first? Who comes first? TCP/IP or OSI? Yeah, TCP/IP. Okay. So when TCP/IP been developed, it was the first one to design and create the infrastructure for it and implement it. Okay. And after the decade when OSI was been developed or created as an evolution of TCP/IP, they found out it will cost a lot to switch from TCP/IP to OSI. So basically OSI, it was nothing but a learning or teaching tool. So like they didn't implement it. They just learn it and teach it to as a plan, but they never implemented because it was cost enough to switch from TCP/IP to OSI, and the cost was really, really significant. Okay? So these two models usually deal with something called protocol layering. Okay? They have a several of layers. Each layer will have their own specific protocols. These protocols are responsible for certain functions, okay, to achieve the data communication. Okay? So when you hear me saying protocols and protocols, what is protocol? You will hear this word a lot, especially in this work. So what is protocol? Is it something like touchable? Does something exist that you can hold it? Yes, it's like a condition. Great, it's like a rule. Perfect. So, for example, like it's the same thing when I told you, okay, if you want to talk to me, I prefer you call me like from 10 to 2 p.m., for example, okay? And please do not call, just give me missed call, and then I will call you back. So I'm giving you what? I'm giving you my rules, my conditions, okay? These like standards for me. If you want to get in touch with me or you want to communicate with me, I'm giving you these certain rules. It's same thing as protocol. Protocol is some kind of rules that both the sender and the receiver should follow, okay? And all the intermediate devices between the sender and receiver also should follow these rules to achieve the communication effectively. Good? Do you understand what is protocol? Good. Great. Okay. So, okay, let's go back to the model. Usually, as I told you, we have two models, TCP/IP model and OSI model. Okay. Let's see the layers. Okay, can you tell me how many layers we have in these models? How many layers? Do you know? 7. Good. In both of them? Both of them have 7? No. Okay. Which? Yeah. Other is 5. Which one has 5? Which one has 7? Okay. TCP have 5 layers. Are you sure? Because I think TCP having 7. Oh yeah, you're right. I was wrong. Yeah, you're right. TCP has 5, and OSI has 7 layers. Do you see the layers now? Do you see them in front of you, the screen? Okay, good. Because this is my first time doing the web sharing, so I want to make sure that you are following me. Okay? Alright, go on. So, as you see, for OSI, we have 7 layers: physical data link, network transport, session, and presentation and application. On the other hand, TCP IP models have 5: physical data link, internet protocol, and transport as well, but I don't know why they write a long name. It's called user data graph protocol, whatever. And the last one is application. Okay. I want you to know something here. Usually, when we talk about the layer number 5 in TCP IP models, we don't say layer 5, we say layer 7. Even though it has only 5 layers, but we always refer to application layer as layer 7 in TCP IP. Can you tell me why? Why I don't call it as a layer 5? Why is it layer 7? And there is only 5 layers. Yes, great, because it combined the 3 other layers, which is session and presentation application. They combined in only 1 layer application. That's why we always refer to application layer in TCP IP models as layer 7. Great, okay. Now, let me talk about the layers one by one. Okay. Physical layer. When I say physical layer, it's too simple. But the first thing it would come to your mind is what? The physical thing in this world. What is it? The most important physical thing in this world that connects the nodes. About bits. Bits. Yes. No, bits is not. It's not physical. You have cable. Good. Cable. So when I told you physical layer, the first thing that should come in your mind is cabling. The cabling usually is the main thing in physical layer. Okay. The most 2 common cable types that's used in the physical layer is the copper twisted pair wire and the optical fiber. Okay. We all agree that computer only understands 2 things, which is 1 and 0, right? So any data will be sent as 1 and 0. Okay. If I'm using copper twisted pair wire, how I'm gonna send this 1 and 0? I cannot send a digital signal. I cannot send 1 and 0. Copper twisted pair wire is only accept the voltage. So, do you have an idea how I can send these 1s and 0s, these digital symbols, through a cable that only allows voltage? Okay. What could happen to the voltage? Usually voltage, it could be what? Okay, let me read that. It will convert to 1 and 0, so it can be converted to what? To a voltage? That's what you mean? Maybe not sure. Yeah, you're right. Be sure. You're right. These 1s and 0s will convert, or not convert, actually, it will be represented as a voltage. The voltage could be high or low. Okay? That's the only thing goes through this cable. It's voltage, it could be high or low. When a voltage is high, that means what? It means 1. Signal is 1. When it's low, it means 0. It's so simple. Okay? So when you receive this voltage and it's saying high, 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 low, 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 high, low, high, high, you will translate that to 1, 1, 1, 0, 0, 0, and so on. Okay? Good? Understood? Okay, great. The other type we have is optical fiber. As I told you the last lecture, these send the signal. There is nothing over there. There is only light. So it's by color. Okay, you will represent this 1 and 0 by the color of light, according to the kind of optical fiber, and it's the fastest. Okay. Also, when we talk about physical layer, there's something else which should be considered as a physical, which is the equipment. What is the equipment in network? Can you give me an example of the equipment that's inside the network? When the data goes from your PC, for example, to the cable and go through the, yes, I get that now. Router, modem, switch, hub, yes. These all are equipment. You could consider that too as well as a physical stuff, and you can consider it in a physical layer. Good. So, good so far? Any question about physical layer? Move on. Great. Okay, let's talk about data link layer now. Data link layer usually it controls the protocols and communication dealing with the physical layer. Okay, they usually prepare the data, okay, to go to the physical layer. The type of data here is usually as a frame. Okay, it will be as a frame in the data link layer. And the most important thing to know here in the data link layer is MAC. What is MAC? MAC is Medium Access Control Supplier. MAC is address. Okay, but address for what? Have you ever heard about MAC? Not MAC, the Apple, no. MAC, the address. Yes. So what is MAC? Address for what? Is it the address for the computer, the destination you are sending to? Memory, no. Every network has MAC, of course. It has more than one MAC. But not network, exactly. Every what? Okay. It is address. MAC is an address for the next node. Okay, and now when you send the data from your PC, okay, or let's go back to our example. When Maria wants to write the message to Anne, okay, she should write what? Have to be two addresses. What is these addresses? You're gonna write your address and an address, right? Maria's address and Anne's address. You're gonna put two of them. Okay? But to send these data, she needs to go to the post office, right? Okay? The post office has an address. And then the post office will look at these letters and say, okay, Maria, she lives in Jeddah, for example. So it's going to send these letters to the post office in Jeddah. So the address of these post offices is MAC. Good? So MAC usually is the address for the node, the next node. And the next node will give the address, the MAC for the next other node, and so on, till they give the node in the final network or for the final destination, and the final node will find these the address for the destination of the network. It's not her address and Anne's, no. It's like the addresses of the box offices. Yes, of course it changed. It doesn't change for the same computer. No, it doesn't change. Now, there is two addresses usually we deal with in network. There is an IP address and there is a MAC address. Okay, IP you're gonna have in the network only two IP addresses. IP address is للكمبيوتر كنتيلة لجهازك لماريا's computer, and then the IP address لAd اللي هو the final destination. Okay. every node you go through كل ما تروحي للسويتش or router it will have its own MAC address. Okay, اللي هي intermediate devices هذه حيكون لها MAC addresses. هتحتاجي هذا الماك addresses عشان تعرفي النكست نود. واضحة؟ الآن حنشرح in the end of the class I'm going to talk about how the data move from your machine to other machine. So حنتكلم عن كل هذه الأدرسز. Now I want you to know that data link layer is the responsible of finding out the MAC address. Okay? Good? If you still don't get it, ask me in the lab. Okay? Right. There is the most used protocols here is Ethernet, Token WAN, and SETI, and 802.11. Good? Okay. Now let's move to the next layer, which is network layer, and also we could call it what? Internet protocol layer or IP layer. دائما ممكن this layer we always call it IP layer, or sometimes we call it network layer. So when I say IP layer, you will know it's network layer, and when I say network layer, you should know it's IP layer. Okay? Okay, from the name, you should tell me what is the most important protocol here in this layer? Waiting, no answers. IP is the most important protocol used here is IP. And it's also there is IPX and ICMP, and these layer usually getting the data from point A to point B. Then it produce the address or find out the address of the final destination. يعني انت مثلا Maria is A and then Anne is B, so it will give you the address of the IP address of your computer, the source, and the address of the destination is Maria or answer. Okay. Good. So this layer is responsible for finding out the address, and it will be responsible to give you the address in every movement through the network. So getting the data, it's mostly responsible for getting the data from, as I told you, from point A to point B. Good. Any question about IP layer? Okay. Now, you have a transport layer, you have a session layer, you have presentation layer, and application layer. Okay. From this layer going up, all these layers are responsible to translate the data to be understandable for the user sitting on the keyboard. These four upper layers responsible only for encoding the data, okay, changing the form of data in every layer. Now in the first layer application, it's just a message. Maybe it's English, maybe it's numbers, okay? So on every layer, it will be change, so it gets to the last layer, which is physical, as a voltage or as a light or whatever, or digital signal, okay? So these are responsible for the security, for the encryption, for the decryption, for compression, for serialization. So they are all handle the message. Nothing. They don't do nothing with what? With the transferring. They just handle the message. Okay. Specifically, if we talk about each of them, transport layers usually handle the error recovery, the flow control, and congestion control, and multiplexation. The protocol used here usually TCP, UDP, user data graph protocol, and SCCP. So here in this layer, if there is an error, لما توصل المسج عندك and it might have some error, this layer is responsible to find out this error. إذا كان الفلو للداتا يعني slow or fast, or there's some data loss in the flow. So they control this flow of data, and the congestion control. Congestion is like if data, sometimes it's, you know, what is happened is data could be written over other data. So this is what's called congestion. They responsible to control the things, and the multiplexing when you part the data to several sections to make it to control the size. So they responsible multiplex this data and demultiplex them when you receive it. Okay, and if we talk about the this is called transport session session is responsible for the authentication and authorization process. Like if you're going to send a username or password, this layer is responsible to find out if you have an account, or if your password is right, or you are the same person that you're supposed to be, or something. So it's like identity check. It's what's happening in this data session. The protocol here is PAP, NetFiles, and PPTP. Yeah. So it's like the police standing the door to check who are you. And then you have the presentation. Presentation layer is responsible to about the data format, how it will be represented. Mostly thing happen here is encryption, decryption. عملية التشفير. It happened here in presentation, okay? And the conversion, serialization, encoding also is happening here. The protocol used is ASCII and XML. You all know ASCII, right? ASCII. I just talked about it the last lecture. ASCII. Have you heard about it? ASCII. Yep. What is ASCII? Let me just check your memory. What is ASCII? ASCII. ASCII. Yes, so it's, yeah, good. It's encoding system for text. Good, great. It's a standard coding system that's used to convert or translate the alphabet, numbers, and other symbols. Right, great. So you sure have a good one. All right. Last layer, application. Put on the name. It's a set of protocols that's responsible to deal with each application. Like for example, if you want to send a file, you want to do some file sharing here. The protocol will be file transport protocol. Then you have SMTP. If you want to send email, it will handle that. And if you want to browse any website, then it will be what? What is the protocol responsible for web browsing? Do you know what is it? HTTP, good. This is the protocol responsible for web browsers. So these protocols are in application layer. It's responsible for that. Good? Good so far? Do you have any questions? Any question about the layer? No questions? Okay. I get nothing from it. Okay. Let's go back to our slide. Do you see the slide? Figure 2.5. You see that? All right, good. So now let's go through the journey. When you create the message or you send the data or whatever, let's see what's happening to this data. How this data moves from A to B, from source to destination. Where this data is going from, which layer it will pass and which nodes and which devices and everything. Okay. So let's assume that we have a 3 PCs here, A and B and C. They are all linked together in one network. And here we have a 3 link 1, link 2, link 3, and there is a router in the middle. These link 1 and link 2 and 3 should be what? Switches. Okay? So, I'm going to send a message from A to B. Okay? Let's go and start with the first layer. Now, step 1. Of course, if the same if your destination is on the same network, do we need the router or not? Now, الآن أنت لما بترسلي data من بيتك مثلا to me, for example, you are submitting your assignment. خلاص. Me and you, are we in the same network? I know we are all using internet, okay, but are we in the same local network? Yes, no, we're not. So, do we need a router in the middle? Do you think there is a router in the middle between me and you? Absolutely, there is a lot of routers. Yeah. Okay. What if you're sending a message to your sister at home? Okay, it's a local network. Is there a router there? Do you need a router? No, good. You don't need a router. If you are in the same network, so there is no need for routing. Why? Because you both have the same IP. Same IP address for this network. So what do you need is, you just need the MAC. Okay? You have a MAC and she has a MAC, then what's going to happen? The switch is like the modem will find, okay, your MAC is in the same network. You are in the same network. So it's just gonna take the message from you and handle it to the other PC that's in the same network. No need for routing. But now we're going to talk how this message is going to go from network, a local network, to another different network. So in the destination is not in the same network. Okay. Okay, let's see. Now I told you everything about the layers. You already know what's happening. Now you have the message in application. See my pointer in application. It's a raw message. Okay. Then in this layer, as I told you, what's going to happen is going to encrypt it, and then it's going to check the authorization or authentication and the multiplexes and all the things handling this message. Okay? Then it will go to what? To transport as well. It will be what? Here. A message. Still the message. Then after the message is ready, خلاص مشفرة وأتأكدوا من السكيورتي أنا مسج عملوا لها تجزية على everything is ready. It will go to the IP network. Here what happened? The message will be a packet. شكل الداتا هنا حاطين packet. Then in data link they will put it in a segment. Okay. And after that will be a frame. Sorry, do I go to the opposite? I'm sorry. Just give me a second. Frame. Yes, frame, bucket, and segment. Yep. Okay. يعني تقريبا الداتا حيحطوها كأنهم بيحطوها في ظرف جوا الظرف جوا الظرف. Okay. So it'll be bucket, then segment, then segment, then bucket, then frame. Yes, yes. In network, it will be segment. In data link, it will be bucket, and then in the physical layer will be a frame. Good. Then after that, the data will change. If you use a copper twisted wire, it will be a voltage, or either will be a light if you're using a byte. What is going to happen قبل ما الداتا تترسل, then هنا your computer is going to send ARP request. ايش ال ARP request اللي هو Address Resolution Protocol. It's going to send a request to what? To this switch. هيرسل طلب للسwitch. Okay? Then default gateway will be used to send this ARP request to get the MAC address for the router. هيرسل عشان ياخذ مين الماك address للراوتر. هيرسل له طلب يقول له please I need the MAC address for the router so I can include it in this message, then I will send it to the destination. A switch is going to respond and return the MAC address to your PC. The MAC will be included in your message, and then after that it will be sent. Okay? يعني الآن المسج حقتك بتطلع معها MAC address للدestination للnext router معها IP address للدestination. يعني أنا الآن الرسالة بحط فيها ال IP address لآخر شيء اللي هي نقطة B، وبنحط فيها كمان الماك address اللي هو next node اللي هو الراوتر اللي أنا أبغى أروحه. واضحة؟ واضحة الفكرة؟ عارفين إيش الفرق بين ال IP address وبين الماك address؟ Do you understand? Okay, I will repeat. Where should I repeat from? من أي نقطة؟ الماك address وال IP address؟ Yes, okay. Now قلت لكم في ال 3 layers الأولى اللي هي الابلكيشن الداتا هيحصل encryption و decryption وتتشفر و everything until it become ready. Then it will be in a packet, بعد كده segment، بعد كده frame. Segment packet frame. Okay? هتنحط أول شيء في segment. السيجمنت هذه هينحط معاها مين؟ ال IP address. Then they will need to do a packet. So علشان يحطوا الباكيت they have to put the MAC address. An ARP request هيترسل طلب على السويتش. السويتش going to respond. هيسأل السويتش يقول له I need the MAC address for the router. Okay? So the switch هيرسل له الماك address للراوتر وهينحط الماك address في الباكيت. بعد كده الداتا هتتحول على شكل فريم اللي هتتغلف تقريبا التغليف النهائي and then it will be sent through the network. هتروح على وين؟ هتروح على switch. Good. هيكون فيها الماك address اللي هو عنوان الراوتر وهيكون فيها ال IP address اللي هو الديستنيشن عنوان الديستنيشن ال P. Good. Good so far? Okay. Then the switch will receive the data. Okay. السويتش دائما يحتاج انه يفك 2 levels من المسج. هيفك لك sorry just a second. Yeah, it will open the frame and the packet. هيفتح الفريم والباكيت بس ما هيفتح السيجمنت. احنا قلنا السيجمنت باكيت فريم. هيفتح اللي هو التغليف الخارجي اللي هو الفريم then we're going to open the packet. ليش هيفتح الباكيت؟ because يحتاج الماك ادرس لانه الماك الادرس موجود في الباكيت لكن السيجمنت فيه له ايش؟ فيه له الاي بي ادرس اللي هو عنوان الديستنيشن. السويتش doesn't need the IP address لانه هو ما يهتم بالديستنيشن هو عليه بالوجهه اللي بعده اللي هي الراوتر. so علشان يحصل على عنوان الراوتر he needs to get the MAC. that's why you will open the frame بعدين هيفتح الباكيت ويتوقف هنا اللي هي لين الداتا لينك. احنا قلنا ان الداتا لينك فيها ايش؟ هي الباكيت. then I will check the MAC address. هيقول okay I know this MAC address. عنده هو تقريبا مخزن العناوين الموجودة في MAC address زي التيبل موجود عنده العناوين الماك address. هيشوف هو موجود السويتش عبارة عن جهاز it has many ports. then it will check which ports it will take me to this MAC address. هيشوف which ports it don't need to be used and then it will send. حيرجع يغلف الداتا مرة ثانية، حيرجع يرجع الباكيت ويرجع الفريم and then it will send it to the router. حيرجع مرة ثانية يغلفها ويرجع يرسلها للراوتر. Good so far؟ احنا وصلنا هنا الآن، وصلنا عند الراوتر. الداتا حقتك الآن your message and the router. Good? Do I need to repeat anything? Okay, good. When you get this to the router now it needs to find out the IP address. هيحتاج إنه يعرف ال IP address. ليش؟ الراوتر usually is separate two networks together. يعني الراوتر هو بيفصل two networks. Why the router needs to know the IP address؟ لأنه من ال IP address هيعرف which network you need to go to. هيعرف أي شبكة أنت حابة تدخليها. Where is your destination? Okay, so it will strip the frame and then the packet, and here you need to strip the segment too. لما يوصل السيجمنت فيها ال IP address. When he gets the IP address, he will find out which network you need to go to. Okay. طبعا كيف هو حيعرف؟ حيبدأ يشوف الراوتر address is the same as destination address. حيشوف هل destination address اللي هي ال IP address اللي انت حطيته في السيجمنت، حيشيك هل هو نفس الادرس تبعه اللي هو الراوتر. إذا كان تبعه حيقول اوكي it's in my network، هي في شبكتي. لكن في حالة إذا كان مختلف حيعرف إنه هو في شبكة ثانية، then he will find out which one is this network، وحيرجع يغلفه مرة ثانية، حيرجع يرجع السيجمنت ويرجع الباكت ويرجع الفريم وحيرسلها للنكست نود. طبعا حتخرج من عنده حتروح على وين؟ على switch. اوكي؟ كده انت خرجتي من النتورك خلاص. and so on هذه العملية بتحصل. حيطلع من النتورك، حيدخل على النتورك، حيطلع من النتورك، ونفس الطريقة كل مرة حيوصل للراوتر. the router is going to check the IP destination address with its own IP address. If it's the same, حيقول it's in my network. If it's not, it will send it to other network. Okay? Till you reach the final router. Okay? Then when you arrive to the network, the destination network, the router is going to check. حيشيك. Okay, this is your destination IP address and his own IP destination address. It will say, okay, this message is coming to my network. هنا حيوقف. It doesn't need to send it to other network. حيعرف الآن حيحتاج إيش؟ الماك address. Okay? So what is going to happen now? ARP request, it will be sent again to the switch. حيرسل الراوتر ARP request again to the switch. حيطلب منه الماك address. Okay? Then the switch will respond with the MAC address. Okay? بعد كده لما يرجع بالMAC address, the router will include the MAC address in the message, and it will frame it again وحيرسلها للسويتش. Now we are here. وصلنا خلاص للسويتش اللي رابط اللي في اللوكال نتورك ل destination C. The switch will check the MAC address and it will find the port. هيشوف البورت اللي يؤدي للدestination. Okay? And then it will send this to the destination. Okay? Your message now on the destination P. Destination P, what is going to do it? It's going to strip the frame, the packet, the segment, the data. بعدين حيعمل عملية decrypt، حيفك التشفير وحيتأكد من authentication or authorization، حيتأكد إنه is this the person who sent this message، and آخر حاجة حيفك الداتا ويرجع لشكلها، يقرأها الريسيفر. Good? Do you understand the movement of data? I know it's a little bit complicated, but but we have to study. Okay? But so far, of course this happens in like less than seconds. هذه العملية بتحصل جزء من الثانية. فحتوصل بسرعة هائلة للديستنيشن. Then the destination ممكن في نفس اللحظة يرجع يرد عليكي. Like when you send a message, لما تكتبي مسج بتحصل هذه العملية. Do you believe it or not? It's same thing happening now. When I talk, صوتي بيتسجل بينحط على مسج بيحصل له نفس العملية segment packet frame and then it will go in the network. حيترسل لي أكثر من network. حيروح لكل واحدة فيكم. في نفس الوقت أنت لما تعملي لي you writing you text to me and you're typing at the keyboard, same thing is happening. You respond to me. You will go through this process again. Do you see this technology? It's amazing. So, any questions? Any questions? We're done. Good. Okay, this one is student saying clear. What about the rest? Good. Good. All right. So, I think this is all for our lecture today. Let me talk a little bit about your assignment. Okay? Now you have an assignment from chapter 1 and chapter 2. I think it might be a section. Some of you have already done the assignment and submitted. And please read the comments. أنا كنت أسألك comments على assignment. When I told you to try again in some questions, that means I'm giving you another chance. أنا بعطيكي فرصة ثانية إنك تصلحي وترجعي تبتدي لي هو. Okay? So whoever submit the assignment and I told her to try again in these questions or these points or whatever or explain more. So go fix it, submit it again. Okay? If you couldn't submit it through Blackboard, send it to me directly by email. Okay? Don't worry. I'll check it and I'll fix your grade. Okay? So as I told you, you still have chances to fix your assignments during the week till Saturday.